Hello, welcome to the next video in the NCB's Home Science Resources. Don't forget to subscribe to our channel so you can get notifications when we upload new videos. I hope you've been enjoying the video so far. Today we're going to be looking at the concept of why oil and water don't mix. So for this experiment you need to get yourself a jam jar of water, some oil, and you also need some fairy liquid. And have you ever tried this? Have you ever seen what happens when oil and water go together? Well, now is your chance, so go and get yourself your water and your oil, and I want you to pour a few drops of the oil into your water jar and see what happens. So, what happened? Well, when I did mine, which I can show you on a video in just a minute, I had my oil droplets, they all went in, they floated around a little bit, and they've now all merged together to form one big surface layer on my water. And I don't know, did that happen to you as well? And you might be wondering, what's going on? Why can't they mix? Why did all of my fat globules start floating and then joining together? Maybe we can make them mix. If we put the lid on our jam jar and you shake it and you keep shaking, are we going to get it to mix? Let's have a look. So what's happened as we've shaken it, you might be able to see inside your jar we've got some tiny fat droplets that have got smaller and smaller, and they've now dispersed within our liquid. But if you leave it on the side for a little bit, you'll see that the oil starts floating to the top again. As we said earlier, it's less dense than water and they will still separate despite the shaking. You might be wondering what's going on and why that's happening. And that's because water and oil are made up of very different kinds of molecules. Water is what we call a polar molecule. So water is made up of two hydrogen atoms, which are slightly positive, and an oxygen atom, which is slightly negative. And this polar molecule is what we describe as being hydrophilic. It's water loving. And things like vinegar and alcohol, they're also hydrophilic. They like water. But here's the problem, because oils and fats, like vegetable oil or butter, they're the complete opposite. They're what we call non-polar, and they like other non-polar molecules. And that's why, when we put them in water, they combine together. And we call this coalescence, when our fat globules are all merging together to form one big mass. The fats and the oils, unlike the water, are hydrophobic. They don't like water, they're water-hating. And so that's why we have oil molecules all sat on the top of our jar of water. So you might be wondering, if things like oil and water can't mix, how do we make products like mayonnaise, which is essentially made from oil and vinegar? Well, in this case, if we look at our ingredients on our mayonnaise has egg in it, and egg is an example of an emulsifier. Now, emulsifiers contain hydrophobic, so remember water-hating, like our oil, and hydrophilic, like our water, ends. So it's got both hydrophobic and hydrophilic ends. And this means that the emulsifier can effectively spread out and hold the hands of both the oil and the water at the same time. So the hydrophobic end can go to the oil, and the hydrophilic end can go to the water. And when this happens, it means that the oil and the water portions can mix together to form what we call an emulsion. And we have lots of emulsifiers used in the food industry. One of them you may see on packaging is called soya lecithin, and that's found in things like chocolate. So have a look at your next chocolate bar and you might see that it's got an additive in there called an emulsifier, which is called soya lecithin. Now, back to our jars. We've got our jar here, and we've shaken it and shaken it and shaken it. We still have, now I've got my oil all on the top of my jar and my water. So what I want you to do now is add a squeeze of fairy liquid. So if you go to the sink and get some washing up liquid and give it a squeeze into your jar. So I now want you to shake your jar with your fairy liquid inside and see what happens. So, as expected, we've got a nice bubbly layer up here of foam, which would normally happen when you wash up anyway. And if I look through my jar now, I don't see any oil in my water. I don't see any big globules of oil anymore, and what's happened is that our oil and water can now mix. We don't have any of the oil layer at the top of our jar anymore, and that's because fairy liquid, like our egg and like our soya lecithin, is an example of an emulsifier. So that's why we use things like washing up liquid when we do our washing up, because we often have fatty pans that we need to wash up, and we need to make sure that we're using something with our water to make all of those fat globules come off of our pans. So that's why oil and water can't mix. And if you join us for the next video, which will be part 2 of our series of emulsions, you will be able to change an emulsion. So in the next video, we're going to be taking double cream and giving it a nice shake and forming butter. So if you want to make butter with us, come back for part 2.